Right. See question number 9. Which one of the following electrolytes has the same value of Vantha factor I as that of aluminium sulphate if all are 100% ionized? Okay. So aluminium sulphate has some Vantha factor. We should find out that. Then among these four, which one has same Vantha factor as that of aluminium sulphate? That we have to find out. Okay, how to do this problem? See, and it is given that all are 100% ionized. Okay, if all the electrolytes are 100% ionized, since it is given 100% ionized, okay, which means the Vantha factor I should be equal to number of ions that is obtained from one molecule of the electrolyte. Okay, so here the given electrolyte is aluminium sulphate. Aluminium sulphate Al2SO4 thrice aluminium sulphate. If aluminium sulphate undergoes complete dissociation, one molecule, if we take one molecule, assume that I am taking one molecule. If one molecule ionizes, I'll get 2 aluminium ion Al3 plus and we'll get 3 sulphate ion SO4 2 minus. So I'll get 2 aluminium ions and 3 sulphate ions from one molecule. Therefore total number of ions is equal to 5. Since number of ion is 5, okay, I and number of ions are equal, therefore Vantha factor for aluminium sulphate is 5. Okay, now what we should do, among the 4 given options, which one will give 5 ions, that we have to identify. If we take option A, in option A we have aluminium nitrate AlNO3 thrice. Okay, if aluminium nitrate undergoes ionization, right, if aluminium nitrate dissociate, I'll get 1 aluminium ion. Okay, I'll get 1 aluminium ion and 3 nitrate ion. Okay, so here 1, here 3, so total number of ion is only 4. Okay, Vantha factor is 4, not 5. So option A is not the correct option. Okay, then what about option B? In option B, the electrolyte given is K4FeCN6. It is a complex ion. It is a complex compound. When complex compound dissociate, okay, all these potassium comes out as potassium ions. So you'll get 4 potassium ions, and this complex exists as a single ion FeCN6. Okay, since each potassium carry 1 plus charge, we have 4 potassium. So there are totally 4 positive charges are there. 4 positive charges. So to balance that, there should be 4 minus charge on this ion. Okay, this is charge, but number of ion is only 1. I got 1 complex ion and 4 potassium ions. Therefore total number of ions is 5 in this case. If total number of ion is 5, Vantha factor also 5. So K4FeCN6, that is potassium ferrocyanide. This compound is called potassium ferrocyanide. Potassium ferrocyanide has same Vantha factor as that of the given aluminium sulphate. Therefore the correct option for this question is option B. Okay, let me check option C and D also. See, in option C we have potassium sulphate K2SO4. K2SO4 will give 2 potassium ion and 1 sulphate ion. So here number of ions is only 3. So Vantha factor is 3 only, right? Therefore this is not the right option. Okay, and in option D we have K3FeCN6 potassium. This is potassium ferrocyanide and this is potassium ferricyanide. Okay, in potassium ferricyanide, see, I'll get 3 potassium ions and 1 complex ion. So total number of ion is, in this case, is 4. Total number of ion is 4. Therefore you'll get Vantha factor as 4. Therefore, among the 4, this is the only compound which will give same number of ions as that of the aluminum sulfate. Okay, therefore correct option is B for this question. Okay, so for this question the correct option is B, right? Then, so for question number 9 the correct option is B option, K4FeCN6, right? Yeah. Now let me go to the next question. Question number 10. Which of them is not equal to 0 for an ideal solution? Which of them is not equal to 0? Okay, this is actually a simple question. You know very well, for ideal solution, question number 10, you know very well, for ideal solution, last class also I gave this. For ideal solution, okay, delta V mixing should be 0, right? Delta H mixing should be 0. Delta H mixing should be 0. Delta U, change in internal energy, mixing should be 0. Okay. Then delta S mixing, right? This should be greater than 0 or it should be positive. And delta G mixing should be negative. Then only you will get a solution. Okay, for ideal solution these things should be 0. Then delta P, here delta P, what I referred is, it is nothing but total pressure that is observed that is experimental, minus total pressure calculated using Raoult's law. Okay, and you know very well, for ideal solution these two are same, these two are one and the same, so you will get the answer as 0. So delta V mixing 0, delta H mixing 0, delta U mixing 0, delta S mixing should be positive, delta G mixing should be negative, and delta P should be 0. Okay, this is these are the some of the conditions of ideal solutions. Okay, so now what we have to do, see the question number 10, which of them is not equal to 0? Among the 4, which is not equal to 0? Delta V mixing should be 0 for ideal solution. Delta P, pressure observed, pressure calculated from Raoult's law, this also should be 0. Delta H mixing should be 0. Delta S mixing, okay, yes, delta S mixing should be positive. It should have some positive value, it cannot be 0. Therefore, the correct option for question number 10 is option D. Okay, it's a very simple question, right? If you remember these datas, right, you can answer this type of questions directly, right? Then let me go to the next question. Question number 11. Question number 11. Students, any doubt in this? Any doubt?
No, sir.
Okay, right. See question number 11. Of the following 0.1 molal aqueous solution, 0.1 molal aqueous solution. Okay, aqueous solution means immediately you should keep in mind that aqueous solution means solvent is water. So here solvent is water, right? Because it's given aqueous solution. Solvent is water. Now I'll read the question fully. Of the following 0.1 molal aqueous solutions, that means all are 0.1 molal aqueous solutions, which one will exhibit largest freezing point depression? Which one will exhibit largest freezing point depression? Okay, you know very well, delta TF is called depression in freezing point. Okay, also called freezing point depression. It is nothing but depression in freezing point. In this question they are asking delta TF is largest. Okay, among the four, which one has the largest delta TF? That's what they are asking. And it is given clearly that all the solutions are 0.1 molar solution. You know very well, delta TF, I'll write here, you know very well, delta TF is equal to Vantha factor I into the cryoscopic constant Kf into molality of the solution. Okay, since all the four solutions, right, that is aqueous, all, that is KCl solution, this is glucose, this is potassium sulphate solution, all the four solutions are aqueous solution. Therefore Kf is same for all the four solutions, because solvent is water. Kf value is same for all the four solutions. What about molality? In the question it is given clearly all the solutions are 0.1 molar solution. So molality also same for all the four options. Okay, since Kf and molality are same, right, therefore I can say delta TF is directly proportional to I only, Vantha factor. If I is high, if I increases, delta TF also increases. Okay, so if you want to find which one has largest delta TF, right, you just find among the four electrolyte or among the four solute particles, which one has the highest value of I. Okay, so in option A, see, in option A it is given potassium chloride. For potassium chloride you will get two ions, right, potassium ion and chloride ion. Therefore Vantha factor for potassium chloride, Vantha factor is 2 for potassium chloride, right. Then in option B, C6H12O6 is given. It may be glucose or maybe fructose. It is a non-electrolyte. Glucose, fructose, sucrose, these are all non-electrolyte. For non-electrolyte, Vantha factor is 1. Right here. For non-electrolyte, Vantha factor is 1. Okay. Then what about option C? In option C, aluminum sulphate is given. Right, option C, aluminum sulphate. Aluminum sulphate, you know very well, Al2SO4 thrice. Okay, there are 5 ions. Okay, each molecule will produce 5 ions. Therefore Vantha factor is 5 for aluminum sulphate. Then the fourth option, potassium sulphate. Okay, it will give 2 potassium ion and 1 sulphate ion. So there will be, each molecule will give 3 ions. So Vantha factor is 3. Now if you compare the Vantha factor, yes, this electrolyte has the highest value of Vantha factor. Therefore delta TF is highest. Okay, delta TF is largest for option C. Okay, just go through the question. What they are asking, of the following 0.1 molar aqueous solution, which one will exhibit largest freezing point depression? Freezing point depression means delta TF. Okay, delta TF depends on I. So among the four, this compound has highest value of Vantha factor. Therefore delta TF is largest for that compound. Okay, so the correct option for this question is option C. Right? Take down. Right, now let me go to the next question. Question number 12. Question number 12. How many grams of concentrated nitric acid solution should be used to prepare 250 ml of 2 molar, capital M means molar, 2 molar nitric acid. Concentrated acid is 70% nitric acid. Okay, right. Students, how to proceed this problem? See, question number 12. Some concentrated nitric acid is there. Okay, some concentrated nitric acid is available, whose percentage is given 70% nitric acid, mass by mass. If it is not mentioned, you should take it as mass by mass. 70% nitric acid is given. What we have to do from this, you have to prepare a solution. You have to prepare a solution of volume 250 ml, 250 ml, and concentration 2 molarity. Okay, so what weight of solution should be taken? What weight of solution, right? So you have to take some mass of solution, and you have to prepare this, right? What mass of solution should be taken, right? Yeah. So how to proceed? First, to prepare this solution, we need to find out how much mass of solution or nitric acid is required. Okay, so it is very simple. We need to prepare molar solution. You know very well, molarity is nothing but number of moles of solute by volume of the solution in liter. I repeat, molarity is nothing but number of moles of solute divided by volume of the solution in liter. Okay, or you can also write number of moles is nothing but mass of solute by molar mass. Mass by molar mass will give you number of moles into volume of the solution in liter. Okay, now we need to prepare 2 molar solutions. So in the place of M, I will put 2 here. Mass of solute we don't know, we have to find out. Okay, mass of solute we have to find out. Then molar mass, nitric acid molar mass, nitric acid formula HNO3. Okay, hydrogen atomic mass 1, nitrogen 14. We have 3 oxygen. Each oxygen atomic mass is 16. So 16 plus 3, 48. Okay, so 48, 52, 62, 63. Molar mass of nitric acid is 63. So in the place of M2, I'll put 63. 63 into volume of the solution in liter. Solution is given in ml, 250 ml. So 250 divided by 1000. To convert milliliters to liter, okay, you have to divide this value by 1000, right? Yeah, so what about the value of W2 now? So W2 is equal to, I'll bring all this term to the left hand side, 2 into 63 into 250 by 1000. Okay, so which is nothing but 2 into 63 into 1 by 4, or 63 by 2. 63 by 2. Let me keep it as such. So you require 63 by 2 grams of nitric acid. Students, observe carefully. To prepare 250 ml 2 molar nitric acid solution, we require 63 by 2 gram of nitric acid. Okay, but we have to take 63.2 gram of nitric acid from this solution. Okay, but the solution given is 70% nitric acid. From 70% nitric acid, we should take some amount, some mass. That solution mass should contain 63 by 2 gram of nitric acid. I repeat, students, we need to take 63 by 2 gram of nitric acid. We require 63 by 2 gram of nitric acid to prepare this solution. But the given solution is 70% nitric acid. From this, you should prepare this. Okay, listen, from the 70% nitric acid, what amount of solution, this solution should be taken such that that solution should contain 63 by 2 gram of nitric acid. Okay, yes, how to do that? It's very simple. Let me write here. You know very well, see here 70% is given, no? So this 70%, nothing has mentioned. If nothing has mentioned, you remember this is percentage mass by mass solution. Percentage mass by mass. Okay, this is nothing but percentage mass by mass. Okay, so what is the definition for percentage mass by mass? Very simple. Mass of solute. Here solute is nitric acid divided by mass of solution. Mass of solution into 100, that is nothing but the percentage mass. So what is the percentage mass given? 70%. Mass of solute by mass of solution into 100 will give you the percentage mass by mass, which is nothing but 70. Now how much solute is required? We require 63 by 2 gram of solute. Okay, so this should be 63 by 2. We need to find out the mass of the solution. what mass of solution should be taken. Okay, so let me write in the next page, or I'll do it here itself. So mass of solute, which is 63 by 2 gram, I'll write here itself, 63 by 2 divided by mass of solution. This is what we need to find out. Let me take it as x, okay, equal to, I'll bring this 100 this side, 70 by 100, okay, or x is equal to, I'll bring x here and 170 to left hand side, x is equal to 63 by 2 into 100 by 70. Okay, I brought this x here and I brought 170 to the left hand side. Okay, so this will give me 0 0 cancel, 1 7 9 7s are 63, 1 2 5 2s are 10, so 9 into 5 45. So x is equal to 45 grams. What does this indicate? If you take 45 gram of this solution, students observe carefully, if you take 45 gram of this solution, that 45 gram solution contains 63 by 2 gram of nitric acid. This is weight of solution, right? If you take 45 gram mass of this solution, that solution contains 63 by 2 gram of nitric acid. Okay, so the correct option, the final answer is 45 gram. So the correct option is option C. Okay, see the question. So the correct option is option C. Right, take down. It is very easy, but it requires some practice. If you solve more problems like this, then you will get some clarity on this, how to proceed. Is this clear, student? Any doubt?
Sir, how do you take the mass of solute as 62 grams?
Mass of, yeah, because here nitric acid is a solute, am I right? We are preparing aqueous solution, okay? Right, we are preparing aqueous solution. So solute is nitric acid here. Okay, we have calculated solute, right? I told you in solution chemistry, 1 represents solvent, 2 represents solute. So this W2 is nothing but mass of solute. So mass of solute, to prepare this solution, you require this much mass of solute. Okay, but they have given some concentrated solution. From this you have to prepare this. Therefore, what we have to do, what mass of this concentrate nitric acid should be taken such that that mass should contain 63 by 2 gram of nitric acid. Is it clear?
How is it the same, sir?
Yeah, because see this solution is 70%, which means it also contains huge amount of nitric acid. Okay, along with you have water also. So to get exactly 63 by 2 gram of nitric acid, what you have to do, here concentration is given, mass by mass concentration, and you know very well mass by mass definition is this: mass of solute by mass of solution into 100 equal to the percentage, right? Percentage given is 70. Now observe this carefully. To get this much mass, once again, yeah, to get 63.2 gram of solute, what amount of solution should be taken? Because we cannot take nitric acid alone from this. Okay, because this is also a solution which contains nitric acid plus water. Am I right? So we cannot take 63 by 2 gram of nitric acid directly from this. So what we have to do, to get 63 by 2 gram of nitric acid, what amount of solution should be taken? Okay, so in the place of mass of solute, I'll put 63 by 2. Right? If I put some value of mass of solution here, let it be x, and calculate that x. Okay, we have calculated that value is 45 gram. That means if you take 45 gram of solution, that 45 gram of solution contains 63 by 2 gram of nitric acid. Is it clear, student?
Yes, sir.
Yeah. So to get 63 by 2 gram, what amount of solution should be taken? That is 45. Okay, right? So for this question, the correct option is C. right? Yeah. Any doubt, students? Any doubt?
No, sir.
Right. Then let me go to the next question. Question number 13. Which condition is not satisfied by an ideal solution? Yes. Can anyone tell me the answer for this question? Which condition is not satisfied? Del S mixing, right? Del S mixing 0 is not satisfied, because delta S mixing should be positive, right, or greater than 0. Okay, so for question number 13, you can write the answer directly. For question number 13, the correct option is B. Why? Because delta S mixing, right? Sometimes they'll write like this also, nothing wrong in it. Delta S mixing, okay, it is given 0. This is wrong. For ideal solution, delta S mixing should be greater than 0. Right? Yes, take 2. Then question number 14. Question number 14. Partial pressure of, students, just go through the question. Partial pressure of A and partial pressure of B, right? The small p represent partial pressure. PA, PB are vapor pressures of pure liquid components A and B. Okay, so these two are pure vapor pressures, respectively. Okay, of an ideal binary solution. If XA represent the mole fraction of component A, the total pressure of the solution will be. So it is given ideal solution, right? Ideal binary solution, right? Two liquids are given A and B. Their pure vapor pressures are PA, PB. PA, PB are pure vapor pressures. And mole fraction is given. Mole fraction A is given. We need to write the expression for total pressure. Yeah, this is a very simple question. See, you know very well total pressure P is equal to, right, partial pressure of A plus partial pressure of B. This is how we write, is equal to, but now according to Raoult's law, partial pressure is nothing but, partial pressure of A is nothing but mole fraction of A into vapor pressure of pure A. For pure A, we use the naught symbol, but here instead of P naught A, the symbol given is PA. In the question it is given PA is the pure vapor pressure. See, PA and PB are vapor pressures of pure liquid component. Therefore, instead of using this P naught, I am going to use the symbol PA itself. Okay, so kindly follow this carefully. Plus, partial pressure of B is nothing but mole fraction of B into pure vapor pressure of B. Actually, I should put a naught symbol here in the superscript. Okay, since in the question the pure vapor pressure is represented as just PA, so I am using the same symbol. Okay. Now, if you go through the options, in all the options, see, mole fraction of A alone is given, right? Mole fraction of A alone, XA is there. There is no XB. So we have to remove this XB. How? It's very simple. Since it is a binary solution, XB is nothing but 1 minus XA. Right? Then XA into PA plus, you just multiply this by PB. So PB minus XA into PB. Right? I have multiplied this and this. Okay, 1 into PB is PB minus XA into PB. Now what we should do? Keep the PB as such. I'll keep the PB as such. Then I'll take XA as common from here and here. So if you take XA common, I'll get PA minus PB into XA. I'll take XA as common. So this is the expression for total pressure. Here, students, keep this in mind. This PB and PA are pure vapor pressures. Okay, so now you just go through the option and find out which one is correct. So in option A, PB minus PA is given. In option B, PA plus is there. PA minus PB is there. Okay, PA minus PB, right? And here we have PA, so this is not correct. In option C, we have PB plus XA into Pb minus Pa is there, so that is also wrong. Option D, we have Pb plus Xa into Pa minus Pbs. So this is the correct answer. Option D is the correct answer. Okay, right, because exactly that matches with this. So option D is the correct answer. Okay, right. Now, is this clear, student? Any doubt here? Any doubt?
No, sir.
Yeah. Actually, remember the standard symbol that we use is this. We put a not symbol for pure vapor pressures. Since in the question it is not given, okay, I didn't use that. Then see question number 15. Question number 15. Vapor pressure of chloroform and dichloromethane at 25 degrees Celsius are 200 millimeter of mercury, 41.5 millimeter of mercury respectively. Okay, pure vapor pressures are given. For chloroform 200 and for dichloromethane it is 41.5 at 25 degrees Celsius. The question is, vapor pressure of the solution obtained by mixing 25.5 gram of chloroform and 40 gram of dichloromethane at the same temperature will be. Okay, at the same temperature will be. You know very well, chloroform and dichloromethane they form ideal solution. Okay, so you have to assume this as ideal solution. Mass of chloroform and mass of dichloromethane are given. So if you mix these two liquids, okay, with this weight, you will get a solution. We need to find out that vapor pressure of the solution, that is total vapor pressure. Okay, yes, how to do that? It's a very simple one. Yeah, it's a very simple question actually. Question number 15. Okay, you know very well, total pressure is nothing but equal to partial pressure of chloroform plus partial pressure of dichloromethane. CH2Cl2 is called dichloromethane, right? And according to Raoult's law, partial pressure is nothing but mole fraction of chloroform into mole fraction into vapor pressure of pure chloroform, right, plus dichloromethane, mole fraction of dichloromethane CH2Cl2 into vapor pressure of pure dichloromethane CH2Cl2 is the formula. You have to multiply these two and you have to add. But how to find the mole fraction? Pure vapor pressures are given. Pure vapor pressure of chloroform and dichloromethane, these two data are available. Mole fraction we need to find out. Okay, yes, how to do that? Listen, mass of chloroform and mass of dichloromethane are given. Molar masses are also given here for your convenience. What you have to do? Find the number of moles. Okay, so number of moles of chloroform is equal to mass by molar mass, right? So what's the mass of chloroform? 25.5 by molar mass of chloroform. Yes, it is given. Molecular mass of chloroform is 119.5. Okay, so if I divide these two, let me give the value directly, but you have to try, you have to simplify this. Okay, but now right now I'll give the answer directly. This comes out as 0.213 moles. Okay, in the examination you have to find out this, okay, by making some mathematical manipulations. Then number of moles of dichloromethane CH2Cl2, right? What's the mass of dichloromethane given? 40 grams. So 40 over molar mass, molecular mass of dichloromethane is 85. So 40 by 85, it comes out as 0.47 value. 0.47. So we have found out the number of moles. Once you know number of moles, you can calculate the mole fraction. Okay, yes, I'll do it here. What's the mole fraction of chloroform? Mole fraction of chloroform equal to number of moles of chloroform 0.213 divided by total. divided by total. Let me write this as 4.0470. If I take the total, it comes out as 38426. So 0.683. This is total number of moles. Number of moles of chloroform divided by total number of moles will give you mole fraction. So what's the mole fraction of chloroform? Mole fraction of chloroform, okay, if you simplify this, you'll get the answer as 0.31. 0.31 is the mole fraction of chloroform here. Similarly, what is the mole fraction of dichloromethane? CH2Cl2. Mole fraction of dichloromethane equal to number of moles of dichloromethane, which is 0.470, divided by total. Total is 0.683 only. Okay, so if I divide this, we'll get dichloromethane, the mole fraction of dichloromethane as 0.69. Actually, you need not do this since it is a binary solution. If mole fraction of chloroform is 0.31, okay, 1 minus 0.31 will give you mole fraction of dichloromethane. You need not do this, but anyway, this is the method you should follow. Students, observe this carefully. If you know mole fraction of chloroform, you can get the mole fraction of dichloromethane just by subtracting this value from 1. Okay, because it's a binary solution. Now I got the value of chloroform, mole fraction of chloroform and mole fraction of dichloromethane. Let me substitute all these things here. Okay, therefore total pressure of the solution equal to mole fraction of chloroform is 0.31 into vapor pressure of pure chloroform is, just see the question in the third line, it is given 200 mm of mercury pressure for chloroform, right? Chloroform is 200 mm. So into 200 plus then mole fraction of dichloromethane, which is 0.69 times the pressure, vapor pressure of dichloromethane, which is 41.5. Right? So if you multiply these two, okay, and these two, and if you add them, you'll get the answer. I'm going to give you the final answer. Okay, I'll just leave it to you. Just simplify and check it whether it is correct or not. Okay, so the final answer is 90.63 mm of mercury. So this is the total pressure we obtained, okay, through this. Okay, I think the answers are not matching. Okay, see options, none of the options have this value. So there may be some problem, right, in the question, I think so. Anyway, you just check it once again. Students, you just multiply these two and check it. Okay, I'll just leave it to you. Right, I got the answer as 90.63. Even you just check it. But 90.63, that option is not there. Right, that means all these options supposed to be wrong. Okay, right. Is this clear, student? Any doubt?
No doubt.
And listen, you know very well, for ideal solution, student, never, if you remember, listen, for ideal solution, if this is the vapor pressure of pure chloroform, suppose this is the vapor pressure of pure dichloromethane, students, observe this carefully. You will get a straight line, right? For ideal solution, you will get a straight line, right? So whatever solution you prepare, the total pressure should not exceed this one. Why? Because this is the highest value. Total pressure should not exceed the value of chloroform. The value of chloroform given, see, that pure vapor pressure of chloroform is 200 only, right? But all these options have values above 200. See, students, are you able to follow? Just see the options given, right? Except the first one, 173.9, all other options are above 200. It is not possible because the vapor pressures of pure vapor pressures of solutions are 200 and 41.5. So the value should not exceed 200. Right? Maybe you just check it whether if you multiply these two, you'll get 173.9 or not. Okay, I got 90.63. Anyway, you just check it. Is this clear, students?
Yes, sir.
Right? Yeah. Good. Then next one, question number 16. Yeah. Freezing point depression constant for water. Freezing point depression constant. That means Kf. Kf for water is given. Kf for water. Okay. It cannot be negative, so I'll just take it as 1.86. 1.86 Celsius per molality. Okay. Right? This freezing point depression constant cannot be negative, so it is given minus 1.86, so don't worry about that, you just take it as 1.86. Then see the second line. If 5 gram of sodium sulphate, 5 gram of sodium sulphate, so this is weight of solute. Okay, let me take it as W2. This is W2, weight of solute. 5 gram of sodium sulphate is dissolved in 45 gram of water. So weight of solvent is 45 gram. Okay, weight of solute is 5 gram, weight of solvent is 45 gram. The freezing point is changed by minus 3.82 degrees Celsius. Okay, the freezing point is changed. That means delta TF is given. Delta TF, freezing point is changed. It should also be positive. Okay, it should also be positive. So let me take it as 3.82 degree Celsius. Okay, per molality. Okay, I'm sorry, degree Celsius. Right. So this is delta TF. Because you know very well, when you add a non-volatile solute in a solvent, freezing point will decrease. Why I am taking positive value? That we know very well. Because delta TF is nothing but freezing point of pure solvent minus freezing point of solution. And you know, freezing point of pure solvent is greater than freezing point of solution. Remember always, when you add a non-volatile solute, freezing point of pure solvent is greater. So this is greater, this is smaller. So delta TF should be positive value. Okay, if the electrolyte is non-volatile, if the solute is non-volatile solute, then delta TF should be positive only. Okay, so in the data it is given, in the problem it is given minus, so it is not minus actually, right? So you take it as positive value, 3.82. Now calculate, okay, what's the question? See, calculate Vantha factor for sodium sulphate. Yes, you know very well, delta TF equal to Vantha factor I into Kf into molality of the solution. You know this formula. Okay, delta TF is given 3.82. Vantha factor we need to calculate. Kf value is given 1.86. All are in the Celsius value. This is also in Celsius. This is also in Celsius. So you need not do any conversion here. Keep it as such, because delta TF, Kf are in the same unit. Then what is the molality? Yeah, you know very well, molality is nothing but number of moles of solute divided by mass of solvent in kilogram. Mass of solvent in kilogram. Or you can also write this as number of moles of solute is nothing but mass of solute divided by molar mass of solute into, suppose if weight of solvent is given in gram, if weight of solvent is given in gram, then you have to divide this by 1000. So W1 by 1000, bring the 1000 to the numerator. So this is the molality formula. So molality is equal to, let me write here, W2 into 1000 divided by M2 into W1. Now all the W2, W1 should be in grams, molar mass should be in gram, so that you will get the answer. Okay, so 3.82 equal to I into 1.86, okay, into the weight of solute. Yes, it is available. Let me write. Weight of solute is 5 grams. 5 into 1000 divided by molar mass of solute. Sodium sulphate is given for sodium sulphate, you need to find out the molar mass. Molar mass, sometime in the question itself they will provide, but now it is not given, so we need to find out. So what is the molar mass of sodium sulphate? See, Na2SO4, right? So we have 2 sodium. For each sodium, atomic mass is 23. So 2 into 23 plus we have 1 sulfur, sulfur 32. We have 4 oxygen, oxygen, each oxygen 16. So 16 into 4, 64. 64. So this is 46 plus 32 plus 64. Okay, so we'll get 164, 70, 110, 142, right? Am I right, student? Molar mass is 142. Is it correct? For sodium sulphate. So let me put that value here, 142 into mass of solvent. Mass of solvent is 45 gram. I'll put that. Okay, yeah. So we'll get an expression. Right, now we have to simplify this. Okay, 1 5s are 5, 9 5s are 45. Right, so I is equal to, I'll bring all this quantity to the left hand side. So I is equal to 3.82 into 142 into 9 over 1.86 into 1000. Okay, so we need to simplify this, right? You just try to simplify this. I will write the answer directly. Okay, for this problem, the value that we get is 2.63. Vantha factor is 2.63. Okay, simplification I'll just leave it to you. It's quite easy only. It's not that tough, so you can easily simplify. Okay, Vantha factor is 2.63. So the correct option for question number 16 is option 2.6 is option B. Option B. Is this clear, student? Any doubt here, students?
No, sir.
Yeah, take it. It's a very simple question. Directly you can answer. Then let me go to the next one. Question number 17. Yeah, students, go through this question carefully. Question number 17. The Vantha factor I for a compound which undergoes dissociation in one solvent and association in other solvent is respectively. Okay, what is the Vantha factor value if it undergo dissociation or if it undergo association? Okay, yes, can you tell me the answer?
Option C, sir.
Option C. Yeah, if it undergo dissociation, it should be greater than 1. Yes, you are right. So you know very well. For non-electrolyte, I have given this already. Anyway, for non-electrolyte, right? For non-electrolyte, Vantha factor is 1. You know very well. When electrolyte undergo dissociation, okay, if electrolyte is given for electrolyte, right, electrolyte may undergo dissociation or sometime electrolyte may also undergo association. If electrolyte undergo dissociation, I value should be greater than 1. If electrolyte undergo association, I value should be less than 1. Okay, so in this question it is given that a compound which undergo dissociation in one solvent, dissociation means I value will be greater than 1, and association in other solvent, so I value should be less than 1. Therefore the correct option is C. Okay, it should be greater than 1 in one solvent and less than 1 in the other solvent, right? It's respectively is given. Now, so let me go to the next question. Question number 18. Yeah, just go through the question, students. A 0.1 molal aqueous solution of a weak acid is 30% ionized. If Kf for water is 1.86 degrees Celsius per molality, the freezing point of the solution will be, okay. Question number 18. 0.1 molar aqueous solution of a weak acid. Okay, so molality is given. Molality is 0.1 molar, right? And it is given 30% ionized, right? It is 30% ionized. Weak acid is given. You know very well, Vantha factor I, or degree of dissociation alpha. Alpha is equal to I minus 1 by n minus 1. I think you may be knowing this. Alpha, right, is equal to I minus 1 by n minus 1. Now degree of dissociation is given. Okay, what they are asking, freezing point of the solution, okay, of a weak acid is given, right? Okay, so what we have to do, you know very well, let me keep this information as such. You know very well, delta TF is equal to Kf into molality into Vantha factor I. Delta TF equal to I into Kf into m. Okay. Now, what is delta TF? Delta TF is nothing but freezing point of pure solvent minus freezing point of solution. Okay. Into I into Kf value is given. Kf for water is 1.86. I'll put the value as such. And molality of the solution, it is given 0.1 molar. I'll put that as such. Freezing point of pure water. Let us take the freezing point of pure water is 0 degrees Celsius. So this is 0. Okay. Or you can also write in Kelvin, but in all the options, see, all the options, the values are given in negative values. Therefore, you can write freezing point of water in Celsius itself. So it is 0 minus freezing point of solution equal to I into 1.86 into 0.1. Okay. Now we need to know what is I. To find I, you require this information. Okay. So alpha is given. What is alpha? Degree of dissociation. In the problem, it is given that the solution is 30% ionized. 30% means 30 by 100. So degree of dissociation is 30 by 100, which is nothing but 0, 0 cancel. So 3 by 10 is 0.3. So degree of dissociation is alpha. I'll put this alpha here. Okay. And the n, for n, they have not mentioned what is the weak acid. Okay, it is given simply weak acid, whether it is acetic acid or oxalic acid. Okay, it may be a monobasic acid or a dibasic acid. There are so many, right? So since it is given simply weak acid, let us assume the weak acid as a monobasic acid, some monobasic acid. Okay, so suppose I will take that acid as RCOOH, some weak acid. If this ionizes, students observe carefully, if this ionizes, I will get RCOO minus and H plus. It does not undergo complete ionization, it will undergo only partial. So it will give you one molecule will produce 2 ions here. One molecule can produce 2 ions, so number of ions equal to 2. I'll put this value here. Therefore, alpha value, okay, is 0.3. I'm substituting in this. Alpha value is 0.3. I we need to find out minus 1 by n value is 2. 2 minus 1 is 1. Therefore, I value equal to, so bring this minus 1 to the left hand side. So you'll get plus 1. 1 plus 0.3, it is 1.3. Okay, so this is the value of Vantha factor. Substitute this value here, 1.3 into 1.86 into 0.1. Students, is this clear? Any doubt? They did not mention what is that weak acid. They didn't give that information. So I am assuming that it is a monobasic acid, right? Take 2. So if you multiply 1.3, 1.86, 0.1, okay, you will get the answer as minus T equal to 0.24. 0.24 degree Celsius, or T is equal to minus 0.2424 degree Celsius. Yes, take down. Is this clear, student? Students, is this clear? Any doubt in this?
No, sir.
Yeah, take down. So the correct option for this question is option D. For question number 18, the correct option is D, minus 0.24 degree Celsius. Okay, take down. Now let me go to the next question. Question number 19. Question number 19. 200 ml of an aqueous solution of protein contains 1.26 gram. Okay, it's 1.26 gram. The osmotic pressure of this solution at 300 Kelvin is found to be 2.57 into 10 power minus 3 bar. The molar mass of the protein will be, okay, they are asking molar mass. Osmotic pressure is given. Okay, I read the question again. Question number 19. 200 ml of an aqueous solution of protein contain 1.26 gram of it. So protein, 1.26 gram of protein is there. Okay, volume of the solution is given. The osmotic pressure of this solution at 300 Kelvin is given, 2.57 into 10 power minus 3 bar. The molar mass of the protein is, okay, yeah. So how to proceed this problem? Students, you know very well, osmotic pressure pi is equal to I into C into R into T. This is the formula. Where I is Vantha factor. Listen, proteins, right, macromolecules are usually assumed as non-electrolytes. Okay, so protein is non-electrolyte, therefore I is equal to 1. Concentration, you know very well, concentration should be in molarity. Molarity. Okay, so in the place of concentration you should put molarity. Molarity is nothing but number of moles of solute divided by volume of the solution in liter. This is the formula for molarity. Into gas constant, or gas constant is given 0.083. See, it is given in the bracket 0.083, right? Gas constant is given in bar unit, liter bar per mole. Liter bar per mole. So it is given in bar unit. So you can use it directly. Temperature is given 300 Kelvin. 300 Kelvin. Okay. Now osmotic pressure is given. What is the osmotic pressure? The osmotic pressure of this solution at 300 Kelvin is 2.57 into 10 power minus 3. So I'll put that here, 2.57 into 10 power minus 3 bar. Okay, what we need to find out? We need to find out the molar mass of protein. Yes, how to do that? So 2.57 into 10 power minus 3 equal to number of moles of solute. What is meant by that? Mass of solute by molar mass of solute. That we know. Volume of the solution in liter. Solution is given in ml, 200 ml. Okay, so 200 ml is given. You should convert this into liter. So divide this by 1000 into 0.083 into 300. Okay, and mass of solute also given, protein mass. How much? It is given, see, 1.26 gram. So let me put that value also. So 2.57 into 10 power minus 3 into mass of solute is 1.26 grams into 0.083 into 300, right? If I divide this 200, 1000, 1 by 5 and bring this 5 to the numerator, 5 divided by molar mass. Or I can write M2 is equal to molar mass of protein equal to 1.26 times 0.083 times 300 into 5 over 2.57 into 10 power minus 3. Okay. So if you simplify this, you will get the answer. Right? You will get the final answer. Okay. Yeah. 9 threes are right. Just multiply these and divide by 2.57. Bring this 10 power minus 3 to the numerator, it will become 1000. Okay, so you'll get some large value, right? You'll get some large value. You just go through the options. Okay, you simplify this, students. I'll just leave it to you. It's very simple only. You have to just multiply all these things and divide by 2.57. You'll get some rough value. So from that rough value, you can easily estimate. Okay, you can easily identify the option. Okay, so I'll just leave this to you. The actual answer is 61038 gram per mole. Okay, you just try and check it whether it is correct or not, right? So the correct option for this question is option D. It is very simple. Just multiply all the 4 and divide by 2.57. You just find it roughly how much you will get. Okay, right? Even if you find the first digit 6, okay, you can answer that, because in all the 4 options, right, only this option has the first digit as 6, so you can easily identify. Okay, students, is this clear? Any doubt here? Hello, students?
Yes, sir.
Yeah, right, good. Now let me go to the next question. Question number 20. An aqueous solution is 1 molal in potassium iodide. Just go through the question. An aqueous solution is 1 molal in potassium iodide. Which change will cause vapor pressure of the solution to increase? Which change will cause vapor pressure of the solution to increase? Okay. Question number 20. Right? Which change will cause vapor pressure of the solution will increase? You know very well. So you know very well the relative lowering of vapor pressure. You might have heard about that. Relative lowering of vapor pressure. Right? What is that? It's nothing but vapor pressure of pure solvent minus vapor pressure of solution divided by vapor pressure of pure solvent is equal to N2 by N1 is equal to N2 by N1 in the case of dilute solution. Okay, this is applicable for dilute solution. For dilute solution. Students, observe carefully. Now, a solution, they are asking an aqueous solution of 1 molal potassium iodide is given. Which change will cause vapor pressure of the solution to increase, right? So we need to increase this. Okay, right? If you want to increase this, if you increase this, students, if you increase this, this difference will decrease, correct? If you increase, if vapor pressure solution increases, because this is a constant. This is constant. If you increase the vapor pressure solution, then the difference will decrease. For difference to decrease, okay, we should increase the number of moles of solvent. Am I right, student? Correct? That is, if left hand side has to decrease, right hand side should also decrease, correct? See what I am trying to say. For vapor pressure, see, we need to increase the vapor pressure solution. For vapor pressure solution to increase, okay, if you increase this, P naught minus P will decrease, am I right? P naught minus P, that will decrease, correct? So left hand side has to decrease. That means right hand side should also decrease. To decrease right hand side, either you should remove solute. Okay, it is a tough task. It's very difficult, but you can add more solvent. If you add more and more solvent, okay, then the denominator quantity will increase. Denominator increases means this ratio will decrease, correct? So for this, N2 by N1 must decrease. This is possible when N1 increases. If you increase N1, okay, N1 is nothing but number of moles of solvent. So if you add more solvent, students, very simple. If you add more solvent, vapor pressure of the solution will increase. Is this clear, student?
Yes, sir.
Okay, so to increase the vapor pressure of the solution, you should add more solvent. So the correct option is addition of sodium chloride, addition of sodium sulphate, see the option D, addition of water, because water is the solvent here. So if you add more solvent, right, the vapor pressure of the solution will increase. Okay, so the correct option for this question is option D. Take 2. What about option C, students? What about option C? If you add same 1 mole solution of potassium iodide in the same solution, will there be any change in the vapor pressure?
Pressure will decrease, sir.
Yeah, there is no change, right? Because the same solution. Already the given solution is 1 mole potassium iodide only. If you add same 1 mole potassium iodide in the same solution, so it remains same. The vapor pressure remains same. Okay. So the correct option for this question is option D only. Right? Yeah. Okay, students, I stop here. We'll continue the remaining things in the next class. If you have any doubt, you can ask me now.